Systems Engineering Lab, final project. The aim of this project was to help companies solve a problem by applying the techniques learned during the Systems Engineering Lab course. The company we're going to help solve a problem is Recogrim. They're a company that specializes in electrolytic industrial coatings. After some research, we found that the company was producing a high percentage of defective pieces that needed to be reworked. With this in mind, we set the following SMART objective. Within the next 6 months, we aim to diminish by 3% the number of pieces that need a type of rework, increasing quality and lowering the costs for the company. Before proposing any solutions, we first analyzed how the company operates right now. In the next diagram, we can see that the company receives pieces from the clients in a raw state. Then, the company inspects the pieces, sends them to a warehouse, and when the work orders are approved, they pass them to the manufacturer zone. The pieces go through 3 main processes, the first of which is the activation of the plastic, following by the adding of copper and nickel layers, and finally, a chrome plating. Between each process, the pieces must undergo different washouts in containers. Pieces are then inspected, packaged, and sent to the clients. Knowing the current state of the company, we used a root cause analysis to find the causes of the problem. One of the root causes found is related to the fact that there are no quality assurance stations in between the processes. Other root causes are related to the fact that the operator is not applying a correct removal of the pieces from the containers. Finally, there's another root cause that is related to having inadequate equipment. Once we knew what the root causes were, we focused on finding a solution for the problem. First, we used the brainstorming technique, which helped us come up with 12 initial ideas. Then we used an affinity diagram to divide the ideas into 4 categories: method, machinery, culture and mindset, inspections. After that, we summarized the ideas into 5 proposed solutions, which are: developing a standard operation procedure, a gadget that reduces the chances of air bubbles forming, special incentives to the workers whenever defects are reduced, organizational culture that makes employees feel responsible for their work, quality assurance after each workstation. Once we had the proposed solutions, the next step was evaluating them through an ISM. To do so, we had the guidance of 3 experts who approved of the solutions proposed. To develop the ISM, we first established the relationships between the proposals. Then we elaborated the initial reachability matrix according to the previous relationships. And following the principle of transitivity, we generated the final reachability matrix. As we can see, the one solution that is clearly independent is the gadget that reduces air bubbles. After some team analysis, we decided that the best 2 options to focus on were the introduction of an organizational culture and the development of an SOP. The SOP will be the immediate action. This will guarantee that every operator applies the same technique for the procedure and that this technique is adequate. Secondly, transitioning into a more responsible organizational culture is always worth it.